Hi everyone, we thought we'd do a short video about the different types of RAID levels out there and how they can help improve your performance and resilience of your storage solution. The first RAID level I'd like to talk about is called RAID 0, which is also called striping. Now RAID 0 doesn't give you any extra resilience on your array, but it does give you a bit of a performance boost. So what happens is that the data comes in and is split simultaneously across multiple disks. This enables you to get a bit of a performance boost. As I mentioned, there's no resilience increase, so we generally don't use this in the surveillance industry because obviously our data is critical. The next RAID level I'd like to talk about is called RAID 1, which is also referred to as a mirrored set of disks. So it's exactly how it sounds, where the set of data on this drive is also replicated on this disk. So you don't get any performance increase, but if you do lose one of these drives, then you don't lose your data. So it's good to have some resilience in there. The shortcomings with RAID 1 is when you have lots of drives, you need twice the amount of disks than actually what you need for storage. So it becomes really inefficient once you start to get into larger disk arrays. One of the most popular RAID arrays that is used is called RAID 5. And RAID 5 is really useful because when you have 3 or more set of disks, you only need to allocate one disk for resilience. So in the case that we have 4 drives here, we only need to allocate 1 drive worth of storage in order to provide resilience on all the disks. So if any of these drives were to fail in a RAID 5 array, you will maintain the data across the whole set of disks. So it's really, really good for resilience. A couple of points to note with RAID 5. The first one is that if you do lose a disk, then it's really important that the disk is replaced as soon as possible, because then all the data on all the rest of the disks is at risk. So if you were to lose another disk, then you lose the data across everything. So it's really important that if you do have a RAID 5 array, to make sure that if a disk fails, that you replace it as soon as possible. Another important note with RAID 5 is there's a big difference between a low-level RAID 5 system, which might be run off a motherboard, compared to a high-end RAID 5 control mechanism using an advanced offload engine, which allows you to not only get the resilience that you want, but to also improve the performance and the functionality of the system as a whole. So there's a big difference in RAID 5 arrays between the type of mechanism you're using to control it. Another popular RAID system is called RAID 6. And RAID 6 is very similar to RAID 5 in that all the data is split across the disks in such a way as it doesn't matter which disk is lost, and you will still maintain your resilience. The difference between RAID 5 and RAID 6 is that you have 2 disks allocated for resilience instead of 1. So if your data is a bit more mission critical, or you have a much larger disk array where there's a higher statistical probability of drive failure over a period of time, then RAID 6 is an option for you. So RAID 6 does lose 2 disks out of the array. So in the case of this 5-disk array, 2 of the drives will be allocated for resilience, and 3 of them is what you'll get in storage. So in this 5-disk, 5 terabyte array, you'll come out with 3 terabytes of usable storage. Once you start getting up into disk arrays that have a large volume of disks, there are a number of methods in which you can increase the performance and reduce the statistical probability of you losing your data. So what we have here is what we call a RAID 50, which is essentially RAID 5 plus RAID 0 combined in such a way as to improve your performance and reduce the chance of you losing your data. So what RAID 50 is it's multiple RAID 5 arrays linked together with striping. So what you can see here is 3 4-disk RAID 5 arrays, and then the data is striped at the top and split across simultaneously across each one of these RAID 5 arrays. So when working out what storage you get and what resilience you have, you can lose 1 disk from each one of these RAID 5 arrays. So in the case of this whole system here, where we have 12 terabytes worth of storage, 12 1 terabyte disks, you will come out with 9 terabytes of usable storage. So RAID 50 is really useful if you've got a large number of disks that you want to store, want to utilize in a single disk array. Another RAID level you can use for large disk arrays is called RAID 60. So it's similar to RAID 50, but instead of RAID 5 plus RAID 0, this is RAID 6 plus RAID 0. So in this case, we have two RAID 6 arrays that are striped at the top. Each one of these disk arrays is called an axle. So in this case, this system would be described as a dual axle RAID 60 array. Now, obviously RAID 60, you lose a bit more disks because RAID 6 requires 2 disks per array. So in the case of this 10 disk system, you would lose 4 disks for resilience, leaving 6 disks for your actual storage. It is quite good though, because you can lose a large amount of disks from this array before you have any problems with losing any data. The last thing I'd like to talk about is hot spares. And a hot spare is a spare disk that's included in the system, ready in case one of the disks in one or multiple RAID arrays fail. So you can have it as a dedicated hot spare for just one disk array, or you can have it as a global hot spare that services multiple disk arrays. It's really useful because, as I mentioned before with RAID 5, if you do lose a disk, it's really important that that disk gets replaced quite quickly. So if you have a hot spare, that'll automatically take place straight away. So there's very little chance of you having problems with your data. The reason why we normally prefer RAID 5 plus hot spare over RAID 6 is because it's a faster performing RAID array, and it has less rebuild time as well. So although we are happy to use RAID 6 in cases where it's needed. So a hot spare is a really, really great thing to have. It's like a spare engineer on site with a disk ready waiting to fix your array, so you can get it resolved as quickly as possible.